In the wastewater, the BOD 5 at 20 degrees centigrade is given as 100 mg per liter, and Kd is given as at 20 degrees centigrade is 0.2 per day. BOD 5 is L0 into 1 minus e power minus Kd into T is 5 days, which is equal to 100 mg per liter. From this, L0 will be equal to 100 by 1 minus e power minus 0.2 into 5, that is equal to 158.197 mg per liter. Whereas in the stream, BOD 5 at 20 degrees centigrade is given as 2 mg per liter, that is L0 into 1 minus e power minus Kd is 0.2 into 5 days, which is equal to 2. From this, L0 ultimate BOD will be equal to 3.164 mg per liter. This is for the this is for the wastewater. Say WW L0 of wastewater, this is L0 of stream, then L0 of mix will be equal to, remember that L0 doesn't depend on temperature. L0 of mix will be equal to discharge of wastewater into L0 of wastewater plus the discharge of stream into L0 of stream by discharge of wastewater plus the discharge of stream, that is equal to wastewater flow is given as 0.2 into BOD is 158.197 plus stream discharge is 5 into L0 is 3.164 by total discharge is 0.2 plus 5. From this, L0 of mix will be obtained as 9.13 mg per liter, whereas the dissolved oxygen of the mix will be equal to Q of wastewater into dissolved oxygen of wastewater plus Q of stream into dissolved oxygen of stream by Q of wastewater plus Q of stream, that is equal to Q of wastewater is given as 0.2 into dissolved oxygen of wastewater is 1 plus Q of stream is 5 into dissolved oxygen of wastewater is 8 by total Q is 0.2 plus 5, that is equal to 7.73 milligram per liter. Initial deficit D0 will be equal to saturation DO, dissolved oxygen saturated, minus DO of the mix. Saturation DO is given as 9 mg per liter, so 9 minus 7.73, which will be equal to 1.27 milligram per liter. We need to determine after 2 days what will be the dissolved oxygen concentration. Let us find at t equal to 2 days what is the deficit, that is dt, which will be equal to L0 into Kd by Kr minus Kd into e power minus Kdt plus e power minus Krt plus D0 into e power minus Krt. Substituting, L0 is 9.13 into Kd is 0.2 by Kr is 0.3 minus Kd is 0.2 into e power minus Kd is 0.2 into T is 2 days minus e power minus Kr is 0.3 into T is 2 plus D0 is obtained as 1.27 into e power minus Kr is 0.3 into T is 2. From this, dt, that is deficit at 2 days, will be equal to 2.916 mg per liter. Deficit at 2 days will be equal to saturation DO minus the dissolved oxygen at that T days. So the dissolved oxygen at T days will be equal to saturation DO, that is 9, minus the deficit 2.916, that is equal to 6.084 milligram per liter.